Hello friends, welcome to our channel, Gajpal A Learning. In this video we are going to study about the topic, that is, precipitating agent, operation involved in precipitation, gravimetry and comparison between volumetric and gravimetric analysis. So let's start the video. Precipitating agent. A precipitating agent, also known as a precipitant or precipitating reagent, is a chemical substance or compound used in chemical reactions to induce the formation of a solid precipitate from a solution. Precipitating agents are essential in various laboratory and industrial processes, including analytical chemistry, chemical synthesis, wastewater treatment, and mineral processing. These agents are chosen based on their ability to react with specific ions or compounds in a solution and cause them to become insoluble, forming solid particles that can be separated from the liquid phase. Here are some common examples of precipitating agents and their applications. First, ammonium hydroxide, NH4OH. Ammonium hydroxide is often used to precipitate metal cations as hydroxide compounds. For example, it can be used to precipitate metal ions like iron, Fa3+, aluminum, Al3+, and zinc, Zn2+, as their respective hydroxides. Second, sodium sulfide, Na2S. Sodium sulfide is employed to precipitate metal ions, particularly heavy metal ions, as metal sulfides. It's commonly used in the qualitative analysis of ions like lead, Pb2+, cadmium, Cd2, and copper, Cu2. Third, hydrochloric acid, HCl. Hydrochloric acid can be used to precipitate certain metal ions as their chloride salts. For instance, it can be used to precipitate silver ions, Ag+, as silver chloride, AgCl. Fourth, sodium carbonate, Na2CO3. Sodium carbonate is used to precipitate metal ions as their carbonates. It is often employed in the analysis of calcium, Ca2+, magnesium, Mg2+, and barium, Ba2+, ions. Fifth, ammonium carbonate, NH4, 2CO3. Ammonium carbonate can be used to precipitate certain alkaline earth metals like strontium, Sr2, and barium, Ba2+, as their carbonates. Sixth, silver nitrate, AgNO3. Silver nitrate is commonly used as a precipitating agent to detect the presence of halide ions, chloride, bromide, iodide, in a solution by forming insoluble silver halide precipitates. Seventh, oxalic acid, H2C2O4. Oxalic acid is used to precipitate calcium ions, Ca2+, and oxalate ions, C2O42, as calcium oxalate, which is sparingly soluble. Note: the choice of precipitating agent depends on the specific ions or compounds being targeted and the desired characteristics of the precipitate. It's important to select a precipitating agent that will produce a precipitate with suitable properties for subsequent analysis or separation processes. Proper control of reaction conditions, such as pH and temperature, is also essential to ensure the success of precipitation reactions. Next is operations involved in precipitation gravimetry. Precipitation gravimetry is a quantitative analytical technique used to determine the concentration of a specific analyte in a sample by precipitating it as an insoluble compound and measuring the mass of the resulting precipitate. The process involves several key operations. First, sampling. Obtain a representative sample of the substance or solution that contains the analyte of interest. The sample should be accurately measured or weighed to ensure precise results. Second, dissolution. If the analyte is not already in solution form, dissolve it in a suitable solvent. This step may require heating or other methods to ensure complete dissolution. Third, precipitation. Add a precipitating agent, also known as a precipitant, to the solution. The choice of precipitating agent is critical and depends on the analyte and the desired precipitate. The precipitating agent should react selectively with the analyte to form an insoluble compound. Fourth, stirring or agitation. Thoroughly mix the solution to promote the reaction between the analyte and the precipitating agent. Adequate agitation ensures that the precipitate forms uniformly. Fifth, filtration. Use a filter paper or a filtration apparatus to separate the solid precipitate from the remaining solution, filtrate. The filtrate contains the excess precipitating agent and any other soluble impurities. Sixth, washing. Wash the collected precipitate with a suitable solvent. The purpose of washing is to remove any residual soluble impurities and excess reagent that might adhere to the precipitate. Seventh, drying. Dry the washed precipitate to remove any remaining moisture. This can be done by heating the precipitate until a constant weight is achieved. The drying process should be carried out carefully to prevent loss of the precipitate. 8. Weighing. Weigh the dried precipitate accurately using a high-precision balance. The mass of the precipitate is a direct measure of the analyte's quantity in the original sample. 9th. Calculation. Calculate the concentration or mass of the analyte in the original sample based on the mass of the precipitate and the stoichiometry of the reaction. This calculation allows you to determine the analyte's concentration or purity in the sample. 10th. Reporting. Express the results of the gravimetric analysis, including the concentration or mass of the analyte, in the appropriate units and with the appropriate level of precision. Ensure that the results are properly documented and reported. Precipitation gravimetry is known for its precision and accuracy when executed with care and attention to detail. It is widely used in analytical chemistry for quantitative analysis of various icons and compounds in research, quality control, and environmental monitoring. Proper control of reaction conditions, thorough washing, and precise weighing are crucial to obtaining reliable results in this analytical technique. Next is comparison between volumetric and gravimetric analysis. Volumetric analysis and gravimetric analysis are two fundamental techniques in analytical chemistry used for quantitative chemical analysis. They have different principles, advantages, and applications. Here's a comparison between the two. First, volumetric analysis. Principle. Volumetric analysis, also known as titration, is based on the measurement of the volume of a reagent of known concentration required to react completely with the analyte in a chemical reaction. Key concept. It relies on the stoichiometry of the reaction to determine the quantity of the analyte. Second, gravimetric analysis. Principle. Gravimetric analysis is based on the measurement of the mass of a precipitate that forms when an analyte reacts with a precipitating reagent. Key concept. It relies on the relationship between mass and chemical composition to determine the quantity of the analyte. Next is measurement. Volumetric analysis involves the use of burettes, pipettes, and titration techniques to measure the volume of the titrant, reagent, added. Endpoint. In volumetric analysis, detection of the endpoint is usually done using indicators, color changes, or other observable changes in the reaction mixture. Measurement. Gravimetric analysis involves precise weighing of the precipitate formed after the reaction with the analyte. Endpoint. In gravimetric analysis, the endpoint is typically reached when no more precipitate forms. Precision and accuracy. Precision. Volumetric analysis can achieve high precision when carried out carefully. Accuracy. In volumetric analysis, the accuracy is highly dependent on the purity and concentration of reagents, as well as the skill of the analyst. Precision. Gravimetric analysis is known for its precision due to the direct measurement of mass. Accuracy. In gravimetric analysis, it tends to be highly accurate when properly executed since it relies on fundamental principles of mass measurement. Applications. First, volumetric analysis. Widely used for the determination of concentrations in solutions. Common applications include acid-base titrations, complexometric titrations, and redox titrations. Second, gravimetric analysis. Used for the determination of the quantity of a specific substance, example, icons or compounds, in a sample. Common applications include the determination of metal icons, anions, and the composition of organic compounds. Advantages and limitations. First, volumetric analysis. Advantages: quick results, suitable for a wide range of analytes, and relatively straightforward. Limitations: accuracy can be affected by the purity of reagents, and some reactions may require careful pH control and indicator selection. Second, gravimetric analysis. Advantages: high precision and accuracy, applicable to a wide range of analytes, and minimal interference from impurities. Limitations: time-consuming, may require additional steps for washing and drying the precipitate, and not suitable for highly soluble substances. In summary, both volumetric and gravimetric analysis have their strengths and weaknesses. Volumetric analysis is often faster and suitable for a broader range of applications, while gravimetric analysis is highly precise and accurate but requires more time and attention to detail. The choice between the two methods depends on the specific analytical requirements and goals. Thanks for watching this video. If this video was helpful, then please kindly subscribe to our channel. Thank you.